Atul sir, hello. Atul sir, hello. Atul sir,
Yes, sir. ಕೇಳಿಸ್ತಿದೆಯಲ್ಲ?
sir, shall we wait for
Yeah,
another 5 minutes? Students are joining.
no problem.
Can I? 3, 5 exactly we will begin, sir.
Okay.
Yeah, thank you. Sir, Sir, you're there?
Yes, sir.
Yeah, yes, sir. I'll give a short introduction about you, sir. Then we can go ahead. Is that fine, sir?
Okay. Yeah, sure.
Okay, yeah. ಇಂದಿನ ಟ್ಯಾಲೆಂಟ್ ಸರ್ಚ್ ಪ್ರೋಗ್ರಾಮ್ ಇದಕ್ಕೆ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ವೃಂದದವರನ್ನು ನಾನು ಸ್ವಾಗತಿಸ್ತಾ ಇದ್ದೀನಿ. ಇಂದಿನ ವಿಷಯ ಬಂದ್ಬಿಟ್ಟು ಮೋಷನ್ ಇನ್ ಅ ಸ್ಟ್ರೈಟ್ ಲೈನ್. ಈ ವಿಚಾರವಾಗಿ ಮಿಸ್ಟರ್ ಅತುಲ್ ಭಟ್ ಇವರು ನಮ್ಮೊಂದಿಗೆ ತಮ್ಮ ವಿಚಾರವನ್ನು ಹಂಚಿಕೊಳ್ಳಲಿದ್ದಾರೆ. ಇವರು ಪ್ರಸ್ತುತ ಕಳೆದ 3 ವರ್ಷಗಳಿಂದ ಪೂರ್ಣಪ್ರಜ್ಞಾ ಕಾಲೇಜು ಉಡುಪಿ ಇಲ್ಲಿ ತಮ್ಮ ಶಿಕ್ಷಣ ವೃತ್ತಿಯನ್ನು ಸೇವೆ ಸಲ್ಲಿಸ್ತಾ ಇದ್ದಾರೆ. ಹಾಗೆ ಇವರು ಅನೇಕ ಸ್ಕೈ ವಾಚ್ ಪ್ರೋಗ್ರಾಮ್ಸ್ ಮತ್ತು ಆಸ್ಟ್ರಾನಮಿ ಬಗ್ಗೆ ಅನೇಕ ಟಾಕ್ಸ್ ಆಗಲಿ ಅಥವಾ ವಿಚಾರ ಸಂಕಿರಣಗಳಲ್ಲಿ ಭಾಗವಹಿಸೋದಾಗಲಿ ಅಲ್ಲಿ ತಮ್ಮ ಮಾಹಿತಿಯನ್ನು ಹಂಚಿಕೊಂಡಿದ್ದಾರೆ. ಹಾಗಾಗಿ ಇವರಿಗೆ ಆಸ್ಟ್ರಾನಮಿ ಬಗ್ಗೆ ಮತ್ತು ಸ್ಕೈ ವಾಚ್ ಬಗ್ಗೆ ಹೆಚ್ಚಿನ ಮಾಹಿತಿ ಇದೆ ಇವರಲ್ಲಿ. ವಿದ್ಯಾರ್ಥಿಗಳು ಇದರ ಸದುಪಯೋಗವನ್ನು ಪಡೆಯಬೇಕಾಗಿ ವಿನಂತಿಸ್ತೇವೆ. ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಮಿಸ್ಟರ್ ಅತುಲ್ ಭಟ್ ಇವರಿಗೆ ಹೃತ್ಪೂರ್ವಕವಾಗಿ ಸ್ವಾಗತಿಸ್ತಾ ಇದ್ದೀನಿ. ನಮ್ಮ ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿಯ ಎಲ್ಲ ಪದಾಧಿಕಾರಿಗಳಾದ ಅಧ್ಯಕ್ಷರಾದಂಥ ಪ್ರೊಫೆಸರ್ ಎಸ್ ಅಯ್ಯಪ್ಪನ್, CEO AM ರಮೇಶ್, ಹಾಗೂ ವೈಜ್ಞಾನಿಕ ಅಧಿಕಾರಿಗಳಾದಂಥ ಆನಂದ್ ಸರ್ ಮತ್ತು ಶ್ರೀನಿವಾಸ್ ಸರ್, ಹಾಗೂ ಸಹಾಯಕ ವೈಜ್ಞಾನಿಕ ಅಧಿಕಾರಿಯಾದಂಥ ಉಮೇಶ್ ಗಾಡ್ಗೆ, ಹಾಗೂ ಎಲ್ಲ ಸಿಬ್ಬಂದಿ ವರ್ಗದ ಪರವಾಗಿ ಸರ್ ನಿಮಗೆ ಮತ್ತೊಮ್ಮೆ ಸ್ವಾಗತ. ದಯವಿಟ್ಟು ತಮ್ಮ ವಿಚಾರಧಾರೆಯನ್ನು ನಮ್ಮ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ದಾರಿ ಎರೆಯಬೇಕಾಗಿ ಕೇಳಿಕೊಳ್ತಾ ಇದ್ದೀನಿ. ಥ್ಯಾಂಕ್ ಯು ಸರ್.
Introduction again. PPT ಕಾಣ್ತಿದೆ ಅನ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ.
ಎಸ್ ಸರ್, ಎಸ್ ಸರ್, ಎಸ್ ಸರ್.
So good afternoon, everyone. Good afternoon to all the participants. We're all here to learn a little about one of the very basic concepts of physics today, that is motion in a straight line. ನೇರ ಸರಳತೆಯಲ್ಲಿ
Atul sir, I'm sorry to stop you. Hello. Hello. Atul sir.
So
Atul sir.
Yes,
Atul
yes,
sir.
yes.
Sir, please turn off your video
Yes,
and then continue with your talk,
Yes,
sir.
sir.
Stop your video and continue just this one, sir.
Okay,
Talk.
okay.
Thank you.
So we need to talk about directions. We need to talk about where is it moving, or is it moving? How do you know it is moving? So in all of physics and mathematics, to relate things with motion, we always have something as the coordinate axis. Cartesian coordinates is the name given to them, basically proposed by Rene Descartes, was a great philosopher who mentioned that any moment in this world that we know can be in the form of 3 axes. One is horizontal axis, one is vertical axis, and one is forward and backward motion. So we call it the x-y axis. If we can only move on the floor, or if we can only move on a wall, like for an ant going on a wall, it can only move horizontally or vertically. It cannot jump out of the wall to move like it does on the wall. So in this case, we will confine this to x and y axis, as it's shown in the image over there. At the center of these axes, we call it an origin. And in physics, you are free to choose wherever the origin needs to be. And this is very useful because when I say motion along one dimension, it need not be horizontal. Sometimes motion can be, a combination of just, both the axes or just one axis. For example, you take this ball, it has moved from the origin towards the x-axis, along the x-axis. Whereas this orange ball, now if I animate it, you'll see it will move along both x and y axis. It has moved this much along x-axis and this much along y-axis. But in physics, the beauty is I can always rotate the frames. I am free to do this. And when I do this, that same orange ball's motion can now be written as a x-axis motion. So this is how we'll simplify all of the calculations. We will assume that any motion today that we are going to talk about is along this one axis. Okay, and then we will understand the physics behind these motions. Okay, and this is very, very, very important because in all of physics, wherever we talk about vectors, wherever we talk about velocity, wherever we talk about motion, movement, acceleration, we need to understand what is discussed. So first, let's understand what are scalars and vectors. This part is in detail explained when we talk about motion in two dimensions, but it is still important for us to understand vectors when we talk about one dimensions, because without vectors, there is no motion along one or the other direction. So what is a scalar? What is a vector? Right? So a scalar is basically a physical quantity that occurs without any direction. So anything that is without a direction, any physical quantity, that is a scalar. I am not a scalar, but my weight or my mass, not my weight, my mass is a scalar. I am on Mars, I am on Earth, I am in space, I am upside down, I'm sleeping, I'm jumping, my mass is always going to be the same. Temperature is another good example. Whenever I'm measuring the temperature, let's say my body temperature, when we were small, doctor used to stick a thermometer under our tongue. And for some of us, he used to put it under our arm. So wherever in the body you measure, the temperature would be the same. So a physical quantity that has no direction. Now you may ask me, sir, this in the thermometer we always see mercury going in one direction. That is mercury's motion. It is in response to the temperature. Now you take these modern thermometers that are digital. There you have no motion at all. It is just measurement. So if I can measure a physical quantity without the need to know its direction, then it's a scale. But if I need a, oh, this should be width. Okay, this should be a width direction. So if I need a direction, if I need to mention a direction for any measurement of a physical quantity, then it is a vector. For example, if I'm running, where am I running? How fast am I running is one question. But in what direction am I running? That is important. Okay. So how do you measure speed? Of course, in our vehicles, we have speedometers. There again, that has no motion. It is just circling around. But then we'll understand why is that so and so on and so. So far, any vector is basically a physical quantity that not only do you measure how much, but you also measure where or what direction. If I'm running, how fast is he running is something that you need to know. That's called the magnitude. Which direction is he running? That is also important. That is my direction. In case of scalars, only magnitude is required. If it's hot, how hot? If it's heavy, how heavy? So these are the basic understanding of scalars and vectors. And when we represent any motion in physics, we will represent it using vectors. So along the x and y axis, of course, you are free to rotate the axis. You are free to move the axis the way you want. But let's say you'll settle down for this axis over here. Now, given the origin, okay, given the origin over here, let's say there's an object over here located from the origin. Then using vectors, I can represent a position vector to this, in which case I will write the vector as a some value, which is basically the length of the vector along this axis till here, a, and x cap is basically my direction along the x-axis. Similarly, it is also high, this much high along the y-axis. So this is b, this length is b, and then y is the direction. So this is how you usually represent a vector. Okay, if it can have z-axis, it can have any axis. But when I say motion in one dimension, again, I will rotate the axis. Now the same motion that I'm defining is along the x-axis. Now here, do I need a vector notation? You tell me. I have the vector a given by ax plus 0y, which means the second term simply becomes 0. Now if I define that the motion is along the x-axis, I don't need to specify the x-axis. However, it is very important for me to add that arrow mark on top of A. That is why I'm telling you what vectors are. If I'm adding an arrow mark on top of the A, then it means that I am specifying the direction. You see, on top of this small a and small b, I'm not putting any arrow mark because that is nothing but the length along here. This much is the length. It can be any direction, here to here or here to here, right? So A and B don't have these arrow marks, but this A, capital A, has an arrow mark. That is very. Even though I do not specify along x-axis, I do not specify x cap or I cap or j cap, this A arrow mark is very, very, very important. Let's talk about distance. What is distance? Usually, my generation, it was my parents who told me this, but in the current the generation of the participants who are there today, your grandparents would have told you. ನಾನು ಚಿಕ್ಕವನಾಗಿದ್ದಾಗ ಸ್ಕೂಲಿಗೆ ಹೋಗ್ಬೇಕಾದ್ರೆ 30 ಕಿಲೋಮೀಟರ್ ನಡ್ಕೊಂಡು ಹೋಗ್ಬೇಕು. ಸೊ ಎಷ್ಟು ದೂರ ಹೋಗ್ಬೇಕಿತ್ತು? How far did you have to travel for school? 30 kilometers, 40 kilometers. Or how far is the shop located if you want to buy something? How far is the shop located? Or whenever you're telling someone wherever you want to go, or he has to go and you tell him the directions on the road, they'll say left or right, which side? After that, he'll say, Eshdura, how far do you have to? So distance is usually the measurement of how far do you have to travel, how far do you have to move from one place to another, and that is basically distance. Okay. Now, usually when I go from A to B, today we all are familiar with Google Maps. So I want to go, let's say, from uh, JP Nagar to Mantri Mall. And how far do I have to go? Then the Google Maps will show me something like this. It will show me two pointers, and of course, if it's JP Nagar and Mantri Mall, it will again say 1 hour 52 minutes, but the distance would be much lesser. Or let's say you're going from Bangalore to Mangalore, in which case the distance would be a very large number of kilometers. So here you see between the 2 points, it says the distance is 187. Not sure if it's clear, it's written over here. 187 kilometers. That is the distance, that much amount of traveling you have to do to go from one place to another. That is known as distance. Displacement is a similar concept, but let's say I have to go from one tree to another tree. I'm putting posters. Okay, that is me on the cycle, or you can imagine yourself. I have to put some posters on these trees. Okay, and I have to put a poster on the tree number A over there, and then unfortunately I brought only one poster, but there are two trees, so I need to go home in between and get another poster. So what will I do? I will put my poster at A, and then I'll go home. Okay, and let's say the home is 4 meters away from the tree, and from home again 3 meters away, I have to go and paste another poster on the tree. So of course, the distance I need to travel is 4 meters to home first, and then home to the tree is 3 meters. That is total of 7 meters. So I will travel a distance of 7 meters to go from tree A to tree C, right? But if from A to C, if I were to travel in the shortest distance, then of course, all of you know, I would take a line directly going from A to C. This is in case I didn't have to go home in between. So let's say I had 20 posters, and then I could directly go from A to C. Then I would take the shortest route. And the shortest distance between 2 points is known as displacement. So here from A to C, of course, it will be uh, okay, it's supposed to go here. This would be how much you can calculate, right? 4 meter. If it's a right angle triangle, you can easily calculate 4 meter and 3 meter. 4 square plus 3 square, it will become 25. That's 5 square. So 5 meters from here to here is the displacement. Go from A to C is the displacement, that is 5 meters. But the distance from A to C that I'm actually taking is 4 meters plus 3 meters, that is 7 meters. So this is the difference between displacement and distance. Distance allowed me to go from A to B and B to C, but the displacement would be directly from A to C. Now you can see that A to C is just one direction, right? I'm going A to C. I'm not saying C to A, I'm saying A to C. So it's going from here to here for 5 meters. Now you see, I said 5 meters, that is the magnitude of displacement. And I also specified the direction A to C. That is why displacement is always a vector. We usually denote it using the S symbol in English or Latin. S with a arrow marking type. So displacement is a vector. Now what's the difference between a distance and displacement? Of course, all of you understood right now, but let me put it in a better picture. Let's say you're running a 200 meters race. Now if you're running a 200 meters race on a racetrack, you would follow this blue line. You would follow this blue line, and you see that the blue line is usually curved initially, and then it goes straight, right? It first curved, nicely takes a nice beautiful curve, then it goes straight. So that 200 meters is covered by running on the tracks. At the same time, you can see that the displacement between the 2 points, the start and the end, is the shortest distance. It need not be the path that I have to take. It is simply the shortest distance, that is from here to here. In which case, of course, it's less than 200 meters, because you see, this is an easier way to travel, right? So this is the distance and displacement difference. You see, for distance, I'm not putting an arrow mark. Why? Because when I'm at the starting point, I'm facing this direction. I'm moving in this direction. As I curve along the route, here I'm traveling in this direction. Here I'm traveling in this direction. And here I'm traveling in this direction. So here at every single point on the curve, my direction is usually the tangent to the circle, right? So if I'm supposed to draw at this point, what is my direction? It is a tangent to this curve. Here, what is my direction? This is the tangent to. So direction keeps on changing till here, and then from here to here, it's a path. So overall, when I'm talking about direction, my direction keeps on changing. That is why distance does not uh, have an arrow mark on top. It is not represented in vector notation. Whereas displacement, of course, it's a straight line, one direction from here to here. Not from here to here, not from end to start, from the start to the end. Single direction, direct movement, one direction, and of course, it has a magnitude which is given by some amount of uh, distance from here to here along this line. Okay, so this is the difference. You can also say that every displacement can be a distance, but every distance cannot be a displacement, because from A here to B here, can be a distance, but the blue line can never be a displacement. So we'll cover that a little while later. If we measure these movements, when I move from A to B along the 200-meter track, or maybe along a road from my house to another tree, each time I usually measure time. Okay, why? Of course, when we take a race, I need to calculate how fast someone reaches. Who's the fastest? So in a 100 meters race or 200 meters race, we usually time it. We add a time clock over there to measure time. And then when that happens, we measure who covered that distance the shortest in the shortest time. So we can measure these distances traveled with respect to time, and this is what leads to a whole world plethora of physics along. So whenever I measure something with respect to time, as in how much something is measured with respect to some measurement in time. For example, when I let's say when I entered the room, okay, when I entered the room, I had one glass of water filling. Okay, water was filling in a glass. When I entered the room, the glass was empty. So I go out, and after 5 minutes, I come back, and then the glass is full. Or at home, if we are going to take bath and we fill the bucket, what do? We switch on the tap and we go somewhere. So when we go somewhere, we switch on the tap, it is empty. But after a while, it will increase. The amount of water will increase. In what time did it increase? The two measurements I made. First, when I switched on the tap, and later when I came inside again. Between these 2 points, I can measure the time. Let's say after 5 minutes when I come, the bucket was full. So in 5 minutes, the bucket was full. So the volume of water in the bucket changed with respect to time. So whenever I make a measurement with respect to time, I will simply call it the rate of change. The rate of change is usually the physical quantity. I've not written anything, it's blank over here. So physical quantity divided by time taken to complete that activity. Okay? So we'll measure things with respect to time over here. So let's measure what is speed. Rate of change of distance. In the simplest form, rate of change of distance is speed. So rate of change of distance is basically the amount of distance covered with respect to time divided by t. Okay, so if time was 1, what would it mean? How much distance would I cover in that 1 second? That is the question. So basically, I can redefine speed as the distance traveled in unit time. If I can travel, let's say 400 meters in 1 second, then my distance, my speed would be 400 divided by 1. Although if I take 10 seconds to complete 400, here I instead of d I will put 400, instead of t I will put 10. So 400 divided by 10 will give me 40. So the value can change, but I can also define speed as amount of distance covered in 1 second. Or I can measure it for 10 seconds and divide it by 10, no problem. Because if the denominator is 1, the numerator simply becomes the answer. And in physics, we can measure distance like this. Of course, please remember the distance is basically how much we travel in a sum total of all directions. What you see here is basically a racetrack. And you see, to move along the racetrack, the car has to move up horizontal down, take a curve. Now you see it's going towards the right, and then slowly afterwards it's going down now, then more towards the right, and then it goes from left to right. Sorry, right to left. So it has to do all of these directional changes, and it completes one complete lap in the race, right? So how much distance does this vehicle take in 1 second? That is to be measured. You can see here they've shown the speed, it's changing constantly, but let's simplify it later for now. The speed can be denoted by any symbol. We usually represent it by V. Okay, speed is V, which is given by the ratio of distance and time, distance versus time. And if you take time as one, easy. The amount of distance covered in that amount of that 1 second is equal to the speed, right? By the way, whatever you're seeing here is the Abu Dhabi Grand Prix track, which is basically 5.5 kilometers long. All of these curves it's taking up, down, right, left, all of these, when you add up how much you've traveled in total from that flag they've shown in between to complete one lap, it is 5.54 kilometers. And the fastest time taken to complete this track has been 1 minute 38 seconds. That's 1.6 minutes. So in 1.6 minutes, you would substitute for speed calculation here. You would put 5.554 kilometers, and here you would put 1.38 minutes, and that would give you the speed, right? So something around 200, 300 kilometers per hour. You can see it there. It's changing and increasing and decreasing. Or this is another idea, as I mentioned earlier, going from one place to another. Don't care about the distance. Don't care about the directions. Look at this example. It says 1 hour 52 minutes to travel 187 kilometers. So speed is given by velocity is equal to distance by time. V is equal to D, which is 187 kilometers, and time is 1.86 hours because 1 hour 52 minutes, right? 52 minutes is 52 out of 60. So you do the calculation. Okay, 0.86. So 1.86 hours it takes to travel 187 kilometers. So what is the speed? 100.53 kilometers per hour. Usually we can represent speed in everyday life. We represent speed in terms of kilometer per hour. Okay. We can also write it as kmph. Modern conventions we write it as kmph. Otherwise it is kilometer per hour. But the SI unit is meters per second. You can convert from kilometer per hour to meters per second. Now we've understood speed. Let's understand another important concept called the velocity. What is velocity? There's a race happening, and in this race, what happens when the gun fires? They all start running. They all start running. And do they change direction? No, they run only along one direction. This is basically an image of a 100 meters track. So what you see here is people are running for 100 meters distance, and you can see the time at the bottom. It is, he's taking Usain Bolt, that famous runner, is taking 9.64 seconds. He runs the 100 meters track in 9.64 seconds. So this is basically the speed. But because he's running only in one direction, we will call it his velocity. So rate of change of displacement, that is one directional change in this motion. The rate of change of displacement is velocity, right? And I can write it as displacement covered divided by time. The rate of change of displacement is equal to displacement covered, which is S usual notation, S or X or whatever, divided by time. In this case, you can calculate the displacement. Usain Bolt's here, velocity is, because it's one direction, velocity is 100 meters divided by 9.6 seconds. But he took 9.64 seconds to travel 100 meters. What if, how much would he travel in 1 second? You can do the same thing. You just divide 100 divided by 9.64, you will get its velocity. And that is usually defined as displacement that occurs in unit time. Rate of change of displacement, or the displacement that occurs in a unit time, is usually defined as velocity. We can calculate the velocity here, by the way. 100 meters covered in 9.64 seconds. You have to calculate the velocity, right? Please note that this is also can be considered as speed over here, because speed is again the same thing. You travel for 100 meters in 9.64 seconds. What's the difference? When you say velocity, you have to specify the direction. In this particular image over here, it is basically you're seeing them run from left to right. So that is one direction. Okay, and you also have the magnitude, which is nothing but the speed, 100 divided by 9.6. So we usually write velocity also as v, but with an arrow mark on. When we add an arrow mark on top, it becomes a vector, because displacement is also a vector. Displacement with respect to time covered is velocity. Let's understand velocity even better. Let's say I have an object, and from the origin it is located at a distance of x1. Okay. At time t1, I will start my stop clock and the object will start moving. So at time t1, the object will start moving. And please understand before I continue the animation, the object will come to some point after some seconds. Let me call it as t2. I will start the stop clock at t1, the object will start moving. When the object stops moving, I will stop the stop clock and that will show me t2, which is some amount of time. Okay, let's do this. So you have the motion from x1 to x2 and the time taken is from t1 to t2. Usually my stop clock shows 0 when I start, so t1 can be 0, no problem. It's up to you. It's up to your measurement. Okay. Now, velocity is measured as displacement, that is d. Okay, I haven't added the vector notation here, but it's the same thing because it's along the x-axis only. Velocity is measured as displacement d. Okay, that's nothing but the difference between the 2 points x1 and x2, and the time taken to go from x1 to x2. That is nothing but the difference between t1 and t2. So if I write it in these terms, the terms that I know, object starts at x1, let's say 1 centimeter from the center, and it reaches x2, which is another 1 centimeters from the center. And to complete this one full motion, it takes 1 second. Okay, let's say the stop clock was reading, initially it was reading 1, and then when it started from x1, I started the stop clock again, and when the stop clock was stopped, it was showing me 2. So x1 is 1, x2 is 2, t1 is 1, t2 is 2. So in that case, what would be my velocity? Simply x2 minus x1, which is 2 minus 1, which is 1, divided by t2 minus t, which is again 2 minus 1, which is 1. 1 by 1, velocity will be 1 meters per second or 1 centimeters per second, or whatever is the distance between 0 to x. Okay? Usually converted to meters per second. This is how we calculate the velocity. The ratio of the distance traveled divided by time taken to travel that distance. In terms of notations, whenever I have difference between the initial and final stage, I will write a capital delta over there, a triangle that. So velocity can be defined as delta x by delta t, the distance traveled in some amount of time. Now let's say I have multiple points. So let's say the object is currently located at x1, and then it starts moving. Okay, and let's see how many points it passes through. So t1 it starts moving, it comes across x2 and then across x3 and then finally stops at x. Here what happens? Earlier I had only x2 minus x1 divided by t2 minus t1. Now I have x2, x3, x4. What will I do? I can basically take the velocity from x1 to x2, which I'll call it as v1. Okay, which I can write it as delta x1 by delta t1. And I can also take it as v2, which is delta x2 by delta t2, which is nothing but distance traveled from x2 3 to x2 and the time taken for that t3 minus t2. Or I can also take v3, which is delta x3, that is x4 minus x3 divided by t4 minus t3. So I can take velocity from here to here, velocity from here to here, and velocity from here to here. In fact, you could have also realized velocity can be taken from here to here also and here to here also. But let's say I will always chop it down to the smallest values. So velocity from here to here is something, velocity from here to here is something, velocity from here to here is something. If an object is moving constantly at 100 km per hour only, then this will be probably equal. Let's find out. So when you have multiple velocity measurements done between 2 points, then the velocity or the average velocity is given by the summation of these 3 or 4 or how much ever measurements you make. Every single term here is nothing but the uh, individual velocity between two points, consecutive points. So what is average velocity? Let's understand from this figure over here. It's supposed to be v1. Okay, it's not v. Sorry, it's supposed to be v, not v1. Ignore the one over there. So v is equal to the first step velocity v1 plus the second step velocity v2 plus the third step. This is the average velocity. It starts from v1, ends with some v2 or v3 or v4 or whatever. In that entire time, I have traveled the displacement. Okay. And why am I considering displacement here? Let's see. You see, the path of travel is not a straight line. It's going around here and there and there. So let's understand this. Delta x1 can be written as x2 minus x1. Delta x2 can be written as x3 minus x2. Delta x3 can be written as x4 minus x3. Similarly, delta t1 can be written as t2 minus t1. Delta t2 can be written as t3 minus t2. And delta t3 can be written as t4 minus t3. In these cases, if I am to process this further, okay, I will simply, here's an addition here, no? Let me simply take these things, values, let me simplify it, and then I will get it like this, somewhat similar like this, okay? Uh, Simplify these calculations, of course, x2 and x2 will cancel here, plus and minus, x3 and x3 will cancel here, so we have got x1 and x4. In fact, I have got x4 as positive, x1 as negative, so x4 minus x1. What is x4 minus x1? This distance, it's usually the displacement. Although I'm traveling a distance, any path taken, in the end, for velocity, I will get x4 minus x1, final position minus initial position. Similarly, time here, you see, t2 can cancel plus t and minus t over here, plus 3 and minus 3 over here, t3. So I've got t4, which is positive, t1, which is negative. So when I write it simpler, it becomes x4 minus x1 divided by t4 minus t. Now, please note when I say average velocity, I'm not taking v1 plus v2 divided by 2. I'm not doing the mathematical average of this. I'm basically measuring the individual velocity for between multiple milestones, and then I'm simply adding them together. Okay. Now, what if velocity itself is not constant? What if velocity changes? Let's see what happens. So, if we have got multiple points here, okay, I will basically not have simply x1, x2, x3, x4. I can have up to x12, x20, x100, or whatever. So in that case, my summation or my addition would be a very long number. That's why I put dot dot dot. N can be any number. I can have 12, I can have 20, I can have 100, I can have 1000. So in that case, when I'm trying to measure the velocity, I have to do it from multiple uh, points and then add them all together. And these have to be continuous. Okay, these have to be continuous. I can skip a velocity in between, then the summation will not be the same. I'll get less value. But when my delta t is very small, because the ball, when it goes from here to here, it takes a very small amount of time. So if my delta t is very, very, very small, then I can write it as limit delta t tending to 0. And if this motion is continuous, if the velocity here keeps changing, okay, velocity is going at distance and displacement are all continuously changing, they're not jumping from one place to another, then I can write this entire velocity term as limit delta t tending to 0, this sum over here, okay? Or whenever I've got 1 plus 2 plus 3 plus 4 dot 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 up to n, I can always write it as uh, summation like this, okay, with the subscript of I. So instead of I can go from 1 to n. So I'll get delta x1 by delta t1 because both I are the same, right? So if I put 1 here, I have to put 1 here. Delta x1 by delta t1 because the summation delta x2 plus delta t2, summation delta x3 plus delta t3, so on and so forth. Now, if this delta t is very, 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 very small than 0, okay, it's almost close to 0, then I can write it as dx by dt. You learn this in limits and continuity in mathematics in the second year. Okay, we can simply write this. What it means is I am measuring the velocity for a very, 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 very small duration of time, or that very small duration of time means I am dividing the movement from A to B into 100 or 1000 or million of pieces. And for that one small amount of time, my position will be here to here, small movement. And in that time, I can measure the velocity. Such a velocity measurement that is calculated for a very, very, very small duration of time while something is in motion is known as instantaneous velocity. Otherwise, to calculate the velocity, I have to calculate his position here, then position here, and then time taken from here to here and divide and do. It's a lot of calculation. We don't have time. We want to measure the speed right now. Imagine you buy a bike, Hayabusa, and then it says, or Ninja if you like it, and then it says 400 kilometers per hour it'll travel. How will you verify it? You have to ride the bike. What if you had to start from home, go around the entire city, or travel for 400 kilometers very fast, at top speed and then stop there, measure the time taken to do that speed and sit and calculate. It would be very boring. Instead, on the way when I'm getting 400 kilometer per hour, I would be very excited. So I need to know the instantaneous velocity for which I can measure the instantaneous velocity by taking this time interval to be very, 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 very small. Okay, I just put an I and I get the instantaneous. Average velocity is the sum of all the different velocities of various sections, and instantaneous velocity is one section's velocity for a very, very, very small interval of time. Now, what is acceleration? Acceleration is nothing but change of velocity, rate of change of velocity. Okay, so whenever a bike is going, if it has some velocity, it is going, and then suddenly it'll start going faster. You can see the camera is going at one speed, it's constantly moving forward, but the bike suddenly starts going forward. It means its velocity is changing. So rate of change of velocity can be written as velocity with respect to time. Here again, if you take time as 1 second, then how much velocity changes in 1 second? Change in velocity per unit time. That is known as acceleration. A is the symbol given usually, and because V is a vector, it has an arrow mark. A also has to have an arrow mark. Acceleration is a vector. Let me understand in terms of picture here. I have V1 measured for the object at T1. As the object moves forward, it reaches one point and I'll measure its velocity to be V2 or V3. Okay. Now let me take four different points. Initially, the object was at zero. Velocity was zero. It was at rest. It was stopping. Then the velocity increased to V2. Velocity increased to V2 and then it started moving, almost reached another point where its velocity decreased to V4 and then it stopped, became 0 to V4. Right? So you can have multiple values of velocity. When the velocity keeps changing like this, we can write acceleration as V2 minus V1 by T2 minus T1, or V3 minus V2 divided by T3 minus T1, or V4 minus V3 divided by T3 minus T4 minus T3. Same as velocity calculation. I can, for that matter, write delta V by delta T. Again, I want to know the acceleration right now, in which case I will simply do the same calculation, apply the limits, and I'll get it as A is equal to dV by dt. Now, please understand velocity is nothing but dx by dt. I got it in the previous slide. Velocity is dx by dt. So if I substitute that over here, I'm taking d by dt of x. I'm taking d by dt twice, in which case I'll write it as second order differentiation, d squared x by dt squared of x. Okay. So rate of change of displacement is acceleration, or rate of change of velocity is acceleration. Does acceleration change? Of course, it can change. Acceleration can also change, in which case we call it a jerk. In physics, we call it a jerk. In which case I will have to take the rate of change three times, d by dt, d by dt, d by dt of x. Or we can write it as d cube 3 by dt cube. Usually you'll find t-shirts like this online saying, don't be a d cube x by dt cube. All they're trying to tell you is, don't be a jerk. Because in English, jerk means a bad person, a nasty person. And in physics, jerk means the rate of change of acceleration. Although you'll not see jerk as much in real life, experiences are also very, very, very minute. So not much studied. Now let's understand the graphical representation of an object. An object at rest. Let's consider this ball over here. It's not going to move along the x or y axis. So I'll measure its position initially. After 1 second when I measure, it is at x coordinate of 1. I'll mark something. After another second, I'll measure its position. It is still at 1 only. So along the x, sorry, this was supposed to be x-axis. So along the x-axis, it is still at 1 only. Here I need to add a point. Again, after 3 seconds, it's still here only. So along the x-axis, it is still at 1. So at time is equal to 3, x-axis is 1. Again, after fourth second, it is still here only. So I'm at another point. Similarly, an object that does not move, that is at rest, if I plot its position versus time, x versus t graph, this is what you get. When you draw the lines, connect the dots, you'll get a string. So perfectly horizontal line on a position versus time graph is for an object at rest. As time keeps changing, the value of time keeps changing, the position of x, the position value of x does not change. It is always at 1 at all points. Similarly, for constant velocity, if an object is having a velocity, okay, but that velocity does not change, it's constant. So initially from 0 at time t is equal to 1, the object has reached x is equal to 1. At time t is equal to 2, the object has not reached x is equal to 2, it has reached x is equal to 3. It has covered 2 of these distances. Time t is equal to 3, it has covered 1, 2, 3 of these distances. So initially it covered 1, next second it covered 2, then it covered 3. So distance keeps on changing, in which case initially at 1 second, the distance covered is 1. After 1 second, okay, on the second, the distance covered is 2. In the third second, how much is the distance covered? It is covered as 3. That is how we can draw the straight. Slope sloped line that is almost exactly 45 degrees is usually in a distance time graph representative of a constant velocity curve. And you can add for acceleration and deceleration, you can draw the curves like this. Okay, these are for distance versus time graph or displacement versus time. Similarly, if you do for velocity versus time, you'll get this exercise. Because velocity, if it is constant, it is not going to change. Then you can get, of course, this acceleration versus time graph. You can do this for velocity versus time and acceleration versus time as well. It is very important for you to understand. It's not in the syllabus right now, I believe. The graphical representation shall not cover it in detail, but it's very important for you to understand how these things work. Next, equations of motion. I told you acceleration is given by rate of change of velocity or delta v by delta t. So when I write delta v by delta t, I will have final velocity minus initial velocity by time. I don't write this subscript. I don't like VF, VI, so I'll simply write it as easier symbols. Final velocity will be written as V, initial velocity will be written as U, in which case my A becomes V minus U by T. Cross multiply, we'll get AT is equal to V minus U, and then finally, just jumble them a little bit, you'll get the final velocity. So an object moving with initial velocity U, if it accelerates with A, then after time t, it has reached a velocity of v. This is the equation of motion. Okay, very important kinematic equation. Similarly, if you do a little bit more complex mathematics, because these are done with integration and differentiation, mostly integration, you don't have integration right now in first view. So for that matter, I will not cover the derivation of these, but these three equations, similar equations, are called the equations of motion. Here V, U, and A and T you know already, but S is also the displacement. So S is the displacement, U is the initial velocity, V is the final velocity, A is the acceleration, and T is time. So for any object, if you know its initial velocity and its acceleration, and the time it takes to reach one point to another, you can calculate the displacement. Sometimes time is not at all a problem. You know both the velocities. It started with some velocity, it ended with another velocity. Time you have not measured, you forgot to measure. You can use this equation to calculate S. Okay, v square minus u square divided by 2a will give you s. So if you know time, you can calculate the distance traveled. If you don't know time, you can calculate the distance traveled. Okay, if you know the acceleration and initial velocity, you can calculate the final velocity, or the vice versa. So these three equations of motion are very important. Now let's understand relative motion quickly. What is relative motion? Whenever I'm measuring something speed with respect to another object, then I'm basically talking about relative velocities or relative motion. For example, here, you look at the bus, it's traveling very fast. You can notice because the road is passing by very fast. But of course, now it is moving very fast. You know, it has a very high velocity. Now, let's say you were in this bus that you're observing, another bus outside, but you could not see the road at all. Then that VRL logo is there only. It is not moving much. So you can say its velocity is very, very, very small. Without this window, velocity was very fast. You can see the road passing by. With this window, velocity is very small. So measurement of velocity is usually relative to something. Is the bus moving? Yes. Of course, here you can see the light is also moving. That's why the bus is moving. Otherwise, velocity variation can be measured. So let me give you an example. Let's say there are two objects. I want to, oh, sorry, ignore this one line, okay? Ignore this line. Consider there's an object A moving, okay, moving forward, and it covers 2 meters in 2 seconds. You can calculate its velocity, calculate its distance. Distance traveled is 2 meters. Time taken is 2 seconds. So distance speed is 2 by 2, which is 1. If it is going to move only along the x-axis, that becomes a velocity. Speed and velocity are the same. Now during this time, let's say the object B is at rest. The object B is at rest and it's going to observe A, and as A moves 2 meters in 2 seconds, okay, you will measure its velocity, or no, velocity to be 1 meter per second, because it has traveled 2 meters in 2 seconds. It will travel 1 meter in 1 second. So that is the velocity measured for A. B has not moved at all. So if you're sitting on B, let's say B is a bus and A is a bus. If you're sitting in B, we'll measure velocity from B of A. Velocity measured of A from B, okay, is 1 meter per second. Similarly, let's say you have A doing the same thing again, but now it covers 2 meters in 4 seconds. Now it's covering 2 meters in 4 seconds. And B is also doing the same thing. Now when A has moved 2 meters, B has also moved 2 meters. So if you're observing A from B, both are together. It has not moved at all. If you're observing A from B, A is still in front of B, or A is still inside of B. It has not moved at all. In which case A has moved 0 meters from B. So velocity is 0. So if you measure A's velocity to be 0.5, because it is 2 meters in 4 seconds. Okay, 2 meters in 4 seconds. B is also moving with the same velocity. So 2 meters in 4 seconds. Velocity is 0.5 itself. What will be the velocity measured by B of A? 0. Because A is not moved anything compared to B. Compared to you, compared to the screen, A has moved, B has also moved. But if you observe only A from B, A is still there. Initially, you can see they were here. Finally, they were here. Here, here. So they have not moved much with respect to each other. That is known as relative motion. Similarly, another case over here. A is moving now 2 meters in 4 seconds, but B has covered only half that distance. It has not completely moved forward. Half that distance in the same time. So it is covering 1 meter in 4 seconds. What is the velocity of A and B? You can see from B's point of view, A has covered only 1 meter, or the distance between A and B is just 1 meter. Because B itself has come 1 meter forward, A is 2 meters, now looks like 1 meter. So velocity of A measured is 0.5, velocity of B measured is 0.25. Because velocity of A is 2 meters in 4 seconds, 1 divided by 2 or 2 divided by 4. Velocity of B is 1 meter traveled in 4 seconds. So 1 divided by 4 is 0. What would be the velocity measured of A from B? A has covered 1 meter in 4 seconds, so it is 0.25 meters. Please note, these first two values are the velocities measured by you on the ground. And this is the velocity of A measured by B. Okay. Quickly, let's do third example. Uh, A is traveling 2 meters in 4 seconds, and B is now covering 3 meters in that same time. Okay. So now what do you see? A has covered 2 meters in 4 seconds, and B has covered 3 meters in the same time. It has covered 1 meter extra, so it has moved forward. Right. Now, from the point of view of B, A is 1 meter behind. So A has traveled 1 meter back in 4 seconds. So what will be the velocity? A's velocity with respect to you is 0.5, because 2 meters in 4 seconds. B's velocity now is 3 meters in 4 seconds. So 0.75, 3 by 4. And velocity of A measured by B is negative, because when you look at B, A has moved backwards in the opposite direction. So it's minus 0.25. Similarly, lastly, let's say B has covered only 1 meter while A covers 3 meters in a complete of 9 seconds. So what will be the velocity? According to B, A has moved only 2 meters forward, because B has moved 1 meter forward, A has moved 3 meters forward. From B's point of view, A is only 2 meters away in time 9 seconds. So you can calculate the velocity to be 0.33 meters per second. Okay, this is with respect to you. You have calculated from the ground. 3 meters in 9 seconds is 0.33. B's velocity, 1 meter in 9 seconds is 0.11. From B's point of view, A's speed is calculated to be 0.22. So understanding all of these numbers, you'll realize relative velocity, velocity measured of A by B. Please understand that order is very important. Velocity measured by B of A is VA minus B, where VA is the velocity of A, VB is the velocity of B. Similarly, VBA is velocity of A measured by B. And if you're measuring velocity of v by a, is the opposite. V minus a. It's supposed to be a by a. This is wrong, but you get the point. Okay, so these are the two questions. I think they've posted it on the chat already, but these are the two questions. If you're on a device, you can take a screenshot or anything, and you can answer these questions and send it to me later. Okay, so like I told you, the Abu Dhabi racetrack is 5.55 kilometer long. Louis Hamilton, a driver, completes that in 1 minute 28 seconds. Okay, 1 minute 28 seconds. You need to calculate the speed as well as his velocity. Okay, you will only consider two values: the starting point position, starting point time, ending point position, and ending point time. Nothing in between. Okay. Similarly, a biker moving with the velocity of 100 km per hour, and you will observe him. You are in a bus and you'll observe him, and you will find his speed is only 43 kilometers. Okay. Oh, sorry. You are in the bus moving at 43 kilometers per hour. So bike is moving at 100. You are moving at 43. What will you measure to be his speed, the bike speed, with respect to you? You are B, bike is A. Please calculate these answers. It will help you understand these problems better. Okay. And if you want to refer any of the books that you want to understand from this concept, these are very good books. The first one and the second one are basically Holy Bible of Physics and PU and graduate studies, undergraduate studies. So it's very important. The third book is also a very nice book. It's a standard textbook for PU. And my email ID is right there at the bottom of the screen. If you have any questions regarding the syllabus related to the topic I've discussed, you can send me an email anytime. Okay. With that, I would like to conclude my talk. Thank you.
Yes, sir. That was very nice to talk, listen to you, sir. I am not a science student, neither I have a background of that, but some here and there, I could figure out that it's informative in a basic science. Uh, yeah. Am I audible, sir, for you?
Yeah.
Hello?
Yeah, I can hear you.
Okay. Seconds. Yeah. Yeah, for the participants, I have posted Atul sir's email ID. You may shoot him the questions regarding your syllabus. And to be frank, that is a more informative session as per my knowledge. I could figure out few things from that. Sir, one small request, the two questions that you posted at the last, can you put on the chat box, sir, if it is possible? Hello? Atul, sir?
Yes, I can hear you.
Yeah, could you
Breaking up.
post those two questions?
Anthony, already I send. Hello.
Okay,
Hello.
okay, 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 okay. Fine,
Already
sir,
I
fine,
sent
sir.
through chat box.
Fine, sir, fine, sir, fine, sir, no problem.
Okay.
ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಇಲ್ಲ ಸರ್ ಇಲ್ಲಿ ಸಿದ್ದೇಗೌಡ ಸರ್
ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಹಾಕಿದ್ದೀನಿ ನಾನು ಆಲ್ರೆಡಿ.
ಇಲ್ಲ ಇದು ಬಂದಿಲ್ಲ.
ಹಾಕಿದ್ದೀನಿ ನನಗೆ ಆಲ್ ಅಟೆಂಡೆನ್ಸ್ ಅಂತಿದೆ ಹಾಕಿದ್ದೀನಿ ಮತ್ತೆ ಗ್ರೂಪ್ ಅಲ್ಲೂ ಕಳಿಸಿದ್ದೀನಿ ಅವ್ರಿಗೆ ಮಕ್ಕಳಿಗೆ.
ಓಕೆ ಸರಿ ಹಂಗಾರೆ ಬಿಡಿ.
ನಿಮಗೂ ಕಳಿಸಿದ್ದೀನಿ ನೋಡಿ ಇದರಲ್ಲಿ
ಆಯ್ತು
ವಾಟ್ಸಪ್ ಅಲ್ಲಿ.
ಆಯ್ತು ಸರ್, ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್.
ಓಕೆ ಥ್ಯಾಂಕ್ ಯು.
Yeah, so to Atul sir, I would like to conclude the session by giving a word of thanks. I thank Atul sir for giving a brief introduction about the physics, the basic calculations of that, how it goes, and where you may go wrong and where you may do it correct, though you were wrong, by making much, sir, giving knowledge to our students through this platform from Karnataka Science and Technology Academy. I thank you on behalf of our President, Professor S. Ayappan, CEO A.M. Ramesh, and scientific officers Dr. Anandar Srinivas and Assistant Scientific Officer Umesh Gadge, and all the staffs here. And also on behalf of the attendees, students, and thanks to Siddhegowda sir for arranging this talk. Thank you very much. And I would like to conclude this session here. So thanks one and all. Thank you very much.
Thank you, sir.
Tomorrow we have 2 sessions from 3 to 5. I request students to attend as much as possible. Please convey your friends also to attend. Thank you very much.